Okay, today we're doing 2-3 curve sketching, and we just need to review how to find quite a few things. We're going to talk about domains, vertical asymptotes, holes, x-intercepts, y-intercepts, and behavior, and even and odd. So where I first like to start is looking at these problems. I'm going to always have you write x-intercept, y-intercept. That will then give you your domain, vertical asymptote, and behavior. We mainly deal with when we're dealing with polynomials, and then we're going to look at horizontal asymptotes. So the first thing, to get x-intercepts, you always have to remember, who do we want to be 0? And that is always set y equal to 0, and then solve for x. On your y-intercepts, we then let x equal 0, so you put 0 in for all the x's, solve for y. Nothing new there, we've talked about them. And then from there, I like to go into your vertical asymptotes. And your vertical asymptotes, let me set this down. Okay, it's where your denominator is equal to 0. And the key thing there, you want to get it in reduced form. So that means simplify, cross anything out. So remember, what do we create if we cross something out of the numerator and denominator? That is a whole. So once we get it into reduced form, then we set the denominator equal to 0, and that's where we will find our vertical asymptotes. Okay, horizontal asymptotes are all about the powers. Just like in the last lesson where we talked about limits of infinity, if the powers are equal in the numerator and denominator, so 2x squared plus 1 over 3x squared minus 1, the powers are the same. So my horizontal asymptote is at y equals 2/3. If the power is greater in the bottom, for example, x plus 1 over x squared minus 1, so notice I created one that also has a hole. This is greater down here, so that means the bottom's growing faster than the top. So then whenever that's the case, the horizontal is always at y equals 0. The third case is when our numerator is greater than the denominator. X squared plus 3x plus 5 over x plus 1. So the top is growing faster than the bottom. So in order to find this horizontal asymptote, we'd have to do synthetic division. And we'll wait until we hit an example like that. That's where we did review this the other day in class. So these are really called oblique asymptotes, but they're still listed under the horizontals. And so I forgot to label our holes. Remember, a hole occurs if something cancels out of the numerator and denominator. So in behavior, it's just talking about if we have those asymptotes, then we know we're going to follow them out horizontally or vertically. So let's go ahead and start with this example. I know I went through each of those definitions really fast, but they should be very familiar to you. Okay, so on the first problem, I want to find x-intercept. So I really, f of x is 0, set that equal to 0. And if I'm looking at a fraction, I only really need to look at the numerator, because once the numerator is 0, then it makes the whole fraction 0. So now we solve for x, and we get negative 2, because subtract that over, x equals negative 2. Now to get the y-intercept, if we notice, this will come down into our domain. Let's factor things out. X, and then we get x minus 2. And we notice nothing's going to cancel, so that I can hurry and go answer there are no holes. But, so on my y-intercept, can x be 0? Well, I know x can't be 0 because that is the vertical asymptote. and I have two values down there. So I have two of them, 0 and 2. So I ended up having no y-intercepts because x could not be 0. So that now comes up to our domain, saying, well, what can x be? Well, I have a rational function that we always talked about. X can be any number except those values that will put 0 in the denominator. So here we know x is in all reals such that x cannot equal, well, what can it equal? Wherever those vertical asymptotes are, or wholes, 0 and 2. So there's my domain. So now we're at horizontal asymptotes. That's all about the powers. I have an x over x squared, which means the power is greater in the denominator. Whenever that's the case, not the limit, but the horizontal is at y equals 0. Okay, so let's go to example number 2. Same thing, x-intercept, y-intercept, HA, wholes. Just get used to writing all this down on your paper. And as I look at it, I can see nothing's going to factor out. So I'm going to address the whole issue right now, that there is none. So now let's do the x-intercept. So to do the x-intercept, we set the numerator equal to 0, and we have the point 0, 0. To get the y-intercept, I put 0 in for all the x's. So 0 over 0 plus 3. Well, 0 over anything is going to be 0. Oh, whoops. I wrote none on HAs instead of wholes. Sorry. So let's talk about the HAs. The powers are greater up top, which means I'm going to have to do synthetic division. But here I have an x squared going into an x cubed, so I can't do synthetic division. I really have to do long division. So we're going to come back to that. It's going to take a little more work. So let's answer our VAs. Our VAs come when we set our denominator equal to 0, and that is at x equals -3. So once I know my VAs and wholes, I know that the domain x cannot equal those values, but it's in all reals such that x cannot equal -3 and 3. So let's go and do that long division real fast. I'm going to have to erase, make sure I have plenty of room. I know some of you are going to be wigging out when I do the long division because it's not so fresh in your head. I need to FOIL that out, which gives me x squared plus 6x plus 9. And now I'm going to go into 2x cubed plus 0x squared plus 0x plus 0. And it just helps to write the zeros out so you can keep everything lined up. So now we just say, how many times will x squared go into 2x cubed? Well, that will go 2x. So then multiply. 2x times 9 is 18x. 2 times 6 is 12, x squared, and then 2x cubed. Now remember, once we multiply it to each term, the next move is to negate each term from there. Well, those cancel. Now I have -12x squared minus 18x, and if you want to do that plus 0, go right ahead. So now we need to figure out x squared, we're going to -12x squared how many times? Well, -12 from here. So -12 times 9 is -108. -12 times 6 is -72x. And -12 times x squared is -12x squared. Next move, negate that bottom. Okay, if you notice when we subtract, we're going to end up with an x here, and x squared won't be able to go into x, so we know this is going to be our remainder. And once we've done our long division, we're not concerned about the remainder. This tells us where our slant asymptote is. So my slant asymptote occurs at y equals 2x minus 12. So if you notice, it's a linear equation that will be guiding our graph. Okay, let's look at example number 3. Now I want you kind of hit pause and you try and do it, and then click play and check to see if you got the same stuff. So remember, get your HAs. Oh, this one had a hole, so obviously I bet you can guess there's going to be a hole. First thing is to do always factor. I've done that for you. You notice right away we get something to cancel out. Now you have to find out where does that hole occur at what x value. If we cancel out x minus 2, I set that equal to 0, so I know the hole occurs when x is 2. But once again, it has to be a point, so we need a y value that corresponds with 2. We'll plug 2 back into your reduced formula. So 2 plus 4 is 6 over 2 plus 2 is 4. So we have the hole at 6/4, which will simplify down to 3/2. So that's where our hole's sitting at. Okay, now let's find our x-intercepts and y-intercepts. Once again, x-intercept being that y equals 0. We're looking at the reduced form because I don't want to catch that hole and call it as an x-intercept. So the only thing that's left up in the numerator is x plus 4. Set that equal to 0, I get negative 4. Y-intercept now, x is 0. Looking at the reduced form, or you could go back to the original. Either one works. 0, 0, 0. So negative 8 divided by negative 4 is positive 2, which I could have seen right here. 0, 0, 4 divided by 2 is 2. Okay, that's just a 1. Okay, so now let's look at our VAs. We know, so this H reduced is would write this part right there. That is your reduced. So now to get our vertical asymptote, set the denominator equal to 0, and that's x equals negative 2. So now we are it's pretty easy to get our domain. X is in all reals such that x cannot equal whatever your vertical asymptote is and whatever your hole is. So x cannot equal 2 or negative 2. Now at your horizontal asymptotes, this is all about the powers. You could look at the reduced, you could look at the original. It's going to be the same. X squared over x squared, powers are the same, so I take their coefficients 1 over 1. So y equals 1. So those are all the important facts that we need to be able to graph these rational equations. And we're going to just learn to graph polynomials. So once again, you can read through those steps right here. And we're going to take a second to pause, and then we'll come back and graph the next one. Okay, so we're going to pick up with their example number 1. We are going to, once again, find the x-intercepts, y-intercept, and I know there's no HAs and VAs because it's a polynomial. There's no x's in the denominator. So these are all the things that we need to look at. We can now discuss the end behavior because it is a polynomial. And we'll be looking at what degree is that polynomial. It's a squared times an x, which is a cube, and a fourth. So we're looking at x to the 4th power. The leading coefficients of all those are 1, so it's positive. So which means I'm thinking like the shape of a parabola. So I know the ends have to be going up. So the way we write the end behavior, the limit as x approaches, and I'm just going to do plus or minus infinity because it's the same both ways, is infinity, meaning both those ends are headed up. Okay, x-intercepts. We set the function equal to 0, and we have 3 pieces here. So that will be, x will be 0. There, set that piece equal to 0. We get x is 1. That piece, we get -2. Now to get the y-intercepts, we put zeros in for all the x's. Well, as soon as I put a 0 right there, it makes the whole thing 0. So, oh, that said y-intercept right there. So there I had the point 0, 0. The domain, since I don't have any x's in the bottom or radicals, the domain is all reals. So now let's plot those points. We have the point 0, 0, 1, 0, -2, 0. And keep in mind, we know our ends have to end up because it's an x to the 4th, it's positive power, it's an even, so it follows the shape of a parabola. And here are our zeros. Now, as we look at our zeros, we pay attention to the powers. This right there means we're going to have a bounce. Like it's going to come down, hit the graph, and then bounce right up. Whenever it's a single power, it goes straight through. So I start down, I hit that 0, I come up, then I'm going to come right there, hit that intercept, and since it didn't have a square, it goes right through, and then turn around and comes right back up. And so there is a basic shape for that. We're just reviewing like these basic things because then we're soon going to get into curve sketching where we're going to label everything. Right? You're going to learn how to find the max and mins and so forth. So there's that example. We're going to look at the next one. They've already haven't reduced form, so I'm looking here. I know we're going to have VAs. They finally labeled everything. So in reduced form, what's going to be left over? That's gone. That's there. So I know there's a hole at 1. Okay. Then that x is gone. And that's down. So my reduced formula is x minus 1 over x plus 3 cubed. And pause. I have a phone call. Okay, so we're back at writing the reduced form with what's left of our function over x minus 3 squared. Okay, so let's hurry and address that hole, because when we plug that value back into the reduced, when I plug 1 in, what do we end up with? Okay, so if I plug 1 in, 1 minus 1 is 0, so 0 over anything is 0. So we have a hole there at 1, 0. Now let's go ahead and address our x-intercepts and y-intercepts. So to get our x-intercepts, we set the numerator equal to 0. Well, we already know that's a hole, so we're not going to include it as our intercept. And then right there we have -3, 0. Oops. Yeah, sorry. Now we're on our y-intercept, put zeros in for all the x's. And once again, let's do our VAs. We have VAs right here at x equals 0 and 3. So that means on our domain, x cannot equal 0, 3, or 1. So on our y-intercept, we normally would let all the x's be 0, but because of this fact right here, we can't ever be 0. So that means I don't have any y-intercepts. And behavior is going to be different here. I don't have a polynomial, so I can't write it out. Nice. Looking at the powers, cubed times an x, there's a fourth, this is a third, so we are left with the power bigger up top, which means I'm going to have a slant asymptote, and we would get that through long division, and we would start out with, because I'm going to have an x to the fourth going into an x cubed. I'm not foiling everything out, but just to kind of let you see, we know that would happen once. That gets me x to the fourth. Then I would negate, and then my next term would be my cubed. So we end up right there with our end behavior, our long division. I should write it out. We have x to the fourth over x to the third. So if I did the long division there, I'd be left with y equals x, which means I just have that horizontal line. So let's come in, draw all that stuff. We want our VAs at 0 and 3. We have our hole at 1, 0, so right there. We have an x-intercept at -3. And we need to draw this slant asymptote. So up 1 over 1, rough sketch right there. So now you should know there's always something to the left and right of every asymptote. So I got a picture, there's something going on here, here, and here. So we need to look at plugging in values to see where these graphs are headed. Well, first off, looking at the right side of the asymptote at 3, I know nothing can be right here because I don't have any x-intercepts. So that leads me to stay up in that section. Now here I could either start at the bottom, hit that hole, and go up. And the other thing we talked about was our evens. Okay, at 3 it's an even, so which means I'm starting up. But if you didn't remember that rule, plug in 2. If I plug 2 into my reduced form, I get positive, 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 so I know I'm up top. And you can cross slants. That's okay. Slants and horizontals can be crossed once in a while, but you will never ever touch a vertical. So now I know this 0 isn't bouncing up because in the reduced form the power is 1. So I know it's going to come back down. But if I didn't know that, I would plug a half in. If I plug in 1/2, it's negative, positive, 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 so I know it's headed down. So now I'm on this piece, and I have asymptotes, and I have a point, so it's pretty easy just to follow it like that. So that's what that crazy graph looks like. Our last graph is one with the radical, and if you remember with radicals, we had 2 horizontal asymptotes. So we gotta watch out for those because our powers are the same. So I'm just gonna start there real fast. HAs, we're gonna have y equals plus or minus 1 because they're coefficients. The square root of 1 is 1, and that is 1. And there's our HAs. So the holes, there are none. VAs at x equals 0. X-intercepts at the top equal to 0. And we get -1, 0. Once again, I know there can't be any y-intercepts because I have a vertical asymptote at x equals 0, so none. which means my domain is x is in all reals such that x cannot equal 0. So now let's draw this information in here. We have the point -1, 0. We have horizontals at 1 and -1. I'm just going to take them down just a little bit. And we have a vertical at x equals 0. So now you're trying to figure out, okay, what is this graph going to look like? So once again, looking to see at our pieces. Where am I going to be? I have something that could be here, or here, or here. How do I know quite where to go? Well, once again, that deals with your points and checking to know where those horizontals truly lie. Does this one continue forever that way, or does it stop? There's no x-intercept, so I know I can't be here. And if I didn't know, we'll plug in a value. If I plug in 2, I get positive over positive, so I know I have to be up here. So this asymptote actually just stopped right there. So I bet you can figure out this side. The horizontal is just really going that way. So now let's plug in. Well, if I have this horizontal asymptote, you don't think I'm going to start down, then come up, and then hit. So plug in -1/2. If I plug in -1/2, I get a positive over positive, so it means I'm starting up. I hit my intercept, and I just follow my horizontal asymptote. So there we go. The end behavior here then, you would just write the limit as x approaches -infinity of that function. So as we go out this way, we approach -1. The limit as x approaches positive infinity of that function, it is headed to +1. All right, so there you have curve sketching. And try and start doing the problem right now. Thanks.